All right, so we're about to learn the power rule, guys. Now, the whole point of all this, when we found derivatives with limits, there's patterns on those. I mean, that's not the whole point. We found an instantaneous rate of change, an instantaneous slope, and we had to do that with limits because you know remember to find the slope you need 2 points. So we made delta x approach 0. Does that make sense? So now you're no longer going to have to do this. Let me minimize this. You're no longer going to have to go. Let's say I tell you what's the derivative of x squared. You're no longer going to have to go limit as h approaches 0 of f of x plus h minus f of x all over h. Let's see. Let's just do it one more time just for fun's sake. F of x plus h, close it, equals parenthesis x plus h, close it, squared, which is x squared plus 2xh plus h squared. And I know you can do it relatively fast. So this is limit as h approaches 0 of x squared plus 2xh plus h squared minus f of x, which is x squared. All this is over h. Notice the x squares cancel out. Notice that I can factor out one of these h's, and h is approaching 0, so I just get 2x. So from now on, we're going to just look at x squared, and you're just going to apply the power rule, and you're going to say, oh, that derivative of that is just 2x. Of course, you don't know what the power rule is just yet. We're about to hit you with it. So let's see. The first one, it says rule number 1. We're not going with the textbook. Derivative of constant. They're telling you the derivative of constant is always 0. Guys, remember, don't be a robot. Why is the derivative of constant always 0? Because that's like saying y equals 5. Remember what derivative means. Derivative means instantaneous rate of change. If I tell you y equals 5, all you're going to do is plot this line here, a horizontal line at y equals 5. What's the slope of a horizontal line? 0. So no wonder that the derivative of any constant is always going to be 0, because you always have constants have, it's just a constant. It has a 0 slope. If I were to plot y equals 10, horizontal line. Y equals 20, horizontal line. Y equals 100, horizontal line. Do we see that, guys? So what's the derivative of any constant? 0. Okay, so check it out. If I say find dy dx for the following functions below, y prime equals 0. dy dx, it's the same thing as saying y prime, equals 0. Oh, look, it doesn't matter. I don't know what 1 trillion there maybe. Y prime or dy dx is 0 again. They're all 0. Okay, here's the moment of truth. And it's not just power rule for positive integers. It can be for negative as well. So let's just call it power rule. It works for all. It's a power rule. It says rule 2. We're not calling it rule 2. We're just calling it power rule. So before I introduce you that, let me just write some random ones. What did you tell me the derivative of x squared was? 2x. I'm just making up some random ones, guys. X to the 5th power. F prime of that, if I were to do the derivative, 5x to the 4th. How did I do it so fast? Look down here. Letter A, f prime of x, that's 2x. F prime of x equals 7x to the 6th. How did I do that so fast? F prime of x equals negative 5x to the negative 6. All right. These are the derivatives if you were to do the limit process. This is the power rule. All the power rule states is you have x to the power n, and look, you bring the n down. So here it is, n down, and you subtract 1 from the power. So let's practice. I'm going to write f prime of x. It says to bring this 2 down, so 2, and subtract 1 from that squared. So 2 minus 1 is 1. There it is. Do you see how we did it, guys? Don't worry. We're going to practice a whole bunch more. Look at letter B.
Teachers, please pardon the interruption. At this time, we still have some 9th graders who are finishing up pictures. Once again, we still have some 9th graders who are still finishing up pictures. So they may be returning a little bit late to class. If we can go ahead and make sure that we correct attendance as students are coming in. And then we will be coming back on the intercom. Actually, at this time, we have finished with our 9th grade just about. If we can have any 10th graders who need to take a picture, and if we have any 8th graders who for some reason were missed on that, any 8th graders who did not get to take a picture, you can also come down.
Bring the 7 down, leave the variable alone, subtract 1 from that variable. There it is. Let's do letter C together. Oops, I put a C there. bring the negative 5 down, and subtract 1 from the exponent. Do you see how we're doing it, guys? All right, look at letter D. Do you think, is that one special? Do we have to do something different with that one? It's the same. All radicals can be turned into an exponent. So before you even do anything, turn this into an exponent. The square root of x is the same thing as what? X to the power 1/2. So now, so here we go. F prime of x. Notice that was not a derivative. That was just rewriting the square root of x. F prime of x is going to be equal to, I'm using the power rule. What do I write first? 1/2. What do I write next? X. What do I do next? Subtract 1 from the 1/2. So what's that going to be? Negative 1/2. They probably want you to write it in square root form. 1/2 square root of x. Have I confused anyone? Are we cool? I just brought it down, guys. Cool. And there it is. Can we do that, guys? So don't turn into a robot. Make sure you understand why. Hopefully you're seeing these are straightforward. Remember, the beauty about math is that there are patterns everywhere. Remember what it means to take a derivative. Because of these patterns, we can now use these rules to just take derivatives in a fraction of the time. So all this means, I have a constant, and it just means constant times derivative c times du dx. So I'm going to do it real quick, guys, but we're never going to do it like this ever again. So look at letter A. Y equals, that 5 is a constant. What is the derivative of x squared? 2x. So I can rewrite this as y prime equals 10x. Guys, you could just go 5 times 2. You can just drop the 2 down. 5 times 2 and then just subtract 1 from the exponent. See? 10x. But we'll do it the way this says it for now. And then until you guys get comfortable. Y prime equals, there's my constant. What's the derivative of x cubed? 3x squared. And we're not done yet. What is 7 times 3? 21x squared. You could have just taken that 3 and multiply it by that 7. See? Yay or nay, guys? All right, here we go. Y prime equals, what's negative 20 times negative 5? 100. And then I subtract 1 from the x. So 100x to the negative from your exponent. To what power? Negative 6. Are we still okay? Before you take the derivative of letter D, turn that into an exponent, guys. 8x to the 1/2. Now we write a new line, y prime or dy dx. Tell me, what do I write? What's half of 8? So I write 4x to the negative half, which is probably best to write it like this. 4 over the square root of x. Because I bring that down, and then I turn that half into an exponent. Into a radical, because they gave it to me in radical form. Is this making sense, guys? Nothing crazy, right? Okay. Don't worry, we're not going to do a whole bunch of them. All this means is to do an element at a time. So the sum and difference rule just means do it an element at a time. So here we go. This means I'm taking the derivative of p with respect to t. So I'm going to write dp dt equals, what's the derivative of t cubed? 3t squared. Done. Go to the next one. What's the derivative of 6t squared? So you could write 6 times 2t, or you could write 12t. The derivative of negative 5/3 t, that's a linear line, or a linear term, really. So it's just going to be a negative 5/3. I know some of you are looking at like, I don't understand that one. What did you just do? Guys, look, I'm going to put it here on the side. You could, if you wanted to, do this. You could say that's the power of 1. Negative 5 thirds times 1 is negative 5 thirds t to the 0. And anything raised to the 0 is just going to be 1. So you could do that. I just showing it just because I want you guys to see it. I always just like to think of this as a linear term. A linear term has a rate of change that's over, like, what are you talking about, linear term? 3x plus 2. This is a linear line. My slope is always 3. Derivative means slope. So since my slope is always 3, if I tell you that y equals 3x plus 2, you're going to tell me that y prime is equal to, say it out loud, 3. You're going to tell me that y prime is equal to 3. Does that make sense, guys? Yeah. So it's the same thing with this. So if you have a 5 thirds t, you're just going to tell me that the derivative is just 5 thirds or negative 5 thirds. The 16 is a constant. What's the derivative of a constant? 0. Done. Leave it alone. This is my answer. How do we feel? Do we feel okay, guys? All right. Don't worry. We're not going to do the product rule. We're pretty much close to being done. All right. Example 5. Find horizontal tangents. Does the curve y equals x to the 4th minus 2x squared plus 2 have any horizontal tangents? If so, where? You do, because you have some wiggles. Every time you have a wiggle, anytime you have something like this, you have a horizontal tangent at your max and your mins. Do you guys see that? Okay, so here we go. So let's find our horizontal tangents by taking a derivative, which tells me how my tangent slopes behave. And I'm going to equal that sucker to 0 to find your x values. So here we go. I'm going to go dy dx equals, what's the derivative of x to the 4th? I never went at the same time. 4x to the 3rd or 4x cubed minus, what's the derivative of 2x squared? 4x. And I'm going to equal this to what? I want horizontal tangents. What's my slope of a horizontal line? I'm going to equal that to 0. That's a constant. What's the derivative of a constant? Okay. Are we okay so far, guys? All right, you're done. It just turns to algebra. I'm factoring out a 4x to make life easier. X squared minus 1 equals 0. I hope that you can see the difference of squares there. I guess I'll show it. 4x, I was just going to go x equals 0 plus minus 1, but x plus 1, x minus 1. The only way this will be true is if x equals 0, if x equals negative 1, or if x equals 1. So this is where I have horizontal tangents. And there it is. That's it. When it says where, I guess let's just write a line. The curve y equals x to the 4th minus 2x squared plus 2 has horizontal tangents at x equals 0, comma, 1, comma, negative 1. Since y prime is 0 at those specific x values. Do you guys want to see the picture? Okay. Let's see the picture. So I'm going to come up here. I'm just going to go to Desmos. And what was the equation again? I'm almost there. Sorry. Different calculator. Come on. Go fast. Okay, y equals x to the 4th minus 2x squared plus what? 2. Oh. Yep, sure enough. Look at this, guys. Negative 1, 0, and 1. You have horizontal tangents. Horizontal tangent. See? Horizontal tangent there, guys. -1, 0, and 1. All right, let's continue. We don't have much left. Find a tangent to the curve y equals x cubed plus x at the points where the slope is 4. What is the smallest slope of the curve, and at what value of x does the curve have this slope? Now, you might not think of it. You might just look at this and be like, wow, that's not even, like, why are we doing these type of questions? Later on, when you guys become an engineer or become a doctor or become a pharmacist, you're going to want to know, like, the thresholds of what's the minimum amount of medicine for this to take to be effective, stuff like that. And you'll see, we're going to be doing application problems later on. All right, here we go. So, I want to know where the slope is 4. So, what do I got to do, guys? Take a what? Take a derivative. So y prime equals, what's the derivative of x cubed? 3x squared plus, what's the derivative of x? 1. Guys, if you just have y equals x, that's a slope of 1. Or, just, all right. I want this slope to be what? So I'm going to equal that sucker to 4. 3x squared equals 3. Since I have x squared, that means x could equal plus or minus 1. Yay or nay? Okay. All right. So I'm going to write a statement real quick. The slope is 4. The slope is 4 when x equals plus minus 1. All right, now I got to answer the second part. What is the smallest slope of the curve? So here's my derivative. What is the smallest this 3x squared plus 1 can be? This is always larger than what? What's the smallest value that this can be? Guys, you guys took algebra and SAT. They gave you SAT questions harder than that. What's the smallest 3x squared plus 1 will ever be? No. But it's a safe space. Thank you. It's 1. Guys, 3x squared plus 1, if you were to graph this graph, would look like this. And the smallest value that you will ever be is 1. Do you guys see that? So the smallest value that the smallest slope that this curve will ever have is 1. So I'm going to write the smallest slope of the curve y equals y equals x cubed plus x is 1. There it is. That's the smallest slope of the curve y equals x cubed plus x is 1. That's the smallest you'll ever be. It'll never be smaller than 1. It's always going to be bigger. So this is how my slope behaves. So the smallest that 3x squared plus 1 will ever be is 1. All my values are larger than that. All the outputs. Cool or not cool? Okay. Let's keep going. Let's see. Okay. Relax. The only thing you know right now is power rule. So I know you're looking at this and you're thinking, Chab, you said we're not going to do product or quotient. We're not. You just need to do algebra. You guys ready? Okay, look. Guys, focus. In the numerator, it's a difference of squares. Yay or nay? So I can rewrite the numerator as x squared minus 25 over x. Are we still all right? You don't know quotient rule. You're not going to do bottom times root to the top minus top times root to the bottom over bottom squared. Unless you already did Khan Academy or something like that. All you're going to do, you're going to take each one and you're going to divide by that single term. X squared over x minus 25 over x. I haven't done derivative yet. What is x squared over x in algebra? It's just going to be what? 1x. And I'm going to rewrite the 25 over x. I'm going to rewrite it like this. 25x to the negative 1. That way I can utilize my power rule. Are we okay so far? Okay. Y prime equals, what's the derivative of x? 1. And then I'm taking the derivative of minus 25x to the negative 1. So what's negative 1 times negative 25? Plus 25. X to the what power? Negative 2. You can rewrite it as 1 plus 25 over x squared. And if you want to turn that 1 into x squared over x squared, which is probably what they want to see, right? So let's turn that into x squared over x squared plus 25 over x squared. And here's your final answer. X squared plus 25 over x squared. We would have taken this answer. This would have been fine. But I turned it into a common denominator of x squared over x squared to make it look the way they presented it to us. Are we okay? Okay. Be careful with linkage errors. As long as they're the equivalent, you're fine. Do not tell me that this top, that top up there is this bottom down there. That would be a linkage error. All right, here we go. Letter B, turn them into exponents. The square root of x is the same thing as x to the what power? 1/2. The cube root of x is the same thing as x to what power? 1/3. Good. Make sure you know your rules of exponents, guys. Your laws of exponents. All right. Next line, write y prime or dy dx. I'm taking the derivative of y with respect to x. Give me the first one. 1/2 x negative 1/2. Okay, go to the next one. What is the next one? Plus 1/3 x negative 2/3. When you're subtracting 1, whatever the denominator is, that's what you're going to do. Minus 3 over 3. Right? That's the 1. So 1 minus 3 is negative 2. All right, let's make it look like this. So here we go. 1 over 2 square root of x plus, let's see, 1 over 3 cube root of x squared. That's the derivative. Ask me questions, guys. Dime. Are we okay so far? Okay. Let's go to letter C. I'm going to rewrite this. Notice I'm just rewriting it, guys. X to the negative 1 minus 3x to the negative 2 plus 75x. Have I tricked anyone? Is anyone super confused? All right, Boston. Hook me up. What's the derivative of x to the negative 1? No, I got you. Bring this negative 1 down. So I'm going to write what? What am I going to say? Negative. Say this number. This number right here. Negative 1. Good. X, and then subtract 1 from that negative 1. So it's going to be a negative what? 2. Good job. And then what's negative times a negative? Positive. So I'm right. Plus, what's negative 3 times a negative 2? 6x to the what power? Negative 3. Good job. Plus, what's the derivative of 75x? 75. Now just do algebra to make it look the way they presented it, guys. Negative 1 over x squared plus 6 over x cubed plus 75. Are we okay so far, guys? Okay. Letter D, here we go. Don't worry. Don't freak out. Turn it into an exponent. This is x to the power 1 times x to the power half plus 8x to the negative 1. So I haven't done anything yet. I'm going to wait for you guys. What is 1 plus a half? Because whenever you multiply the same bases, you add up the exponents, right? So what's 1 plus a half? 3 over 2, 1.5. I haven't taken the derivative yet. Y prime equals, what's the derivative of x to the 3 halves? 3 halves x to the 1 half. You just subtract 1 from the 3 halves, guys. Minus 2 over 2. And then what do I write for the next one? Minus 8x negative 2. Let's rewrite it. 3 squared of x over 2 minus 8 over x squared. Anyone know Pascal's triangle, guys? By chance? No? Okay. That's fine. This one here, let's go ahead and expand it. X minus 5 squared times x minus 5. Notice, I'm thinking of you guys. I'm not adding more. I'm not going to do it with Pascal's triangle. Mental health. I'm just doing it with what we know. We can expand this one pretty fast, no? Yeah. X squared minus 10x plus 25 times x minus 5. If you want to know Pascal's triangle, come by after school. We'll teach it to you real quick. All right. All I'm going to do is I'm going to multiply all these suckers with everything on this binomial here. So here we go. I'm still doing y. This is just y. X squared times x. X cubed. X squared times 5. Minus 5x squared. You're done. You're done with the x squared. Go to the negative 10x. Negative 10x times x. Negative 10x squared. Negative 10x times negative 5. Plus 50x. Done with that one. 25 times x. 25x. 25 times negative 5. Minus 125. Okay, let's put everything in order. X cubed. These two right here minus 15x squared. These two right here plus 75x minus 125. I don't see any errors. Let me know if you see any. All right, here we go. Y prime. What's the derivative of x cubed? What is it? 3x squared. What's the derivative of 15x squared, guys? Minus 30x. What's the derivative of 75x? Plus 75. Done. Okay, this is the last one. And then you just have delta just to practice power rule, and that's all we're practicing. Should be pretty short. Should be pretty short. I would like for you guys to recognize, but if we don't recognize, that's okay. I would like if you were to be able to recognize this as something. Do you guys recognize that one? It's a difference of cubes. But if you don't recognize it, that is okay. That is fine. This is the difference of cubes. You would get x cubed minus 8. But if you don't recognize it, here we go. Take that x, multiply it by everything in that trinomial. So here we go. Y equals x cubed plus 2x squared plus 4x. Done with that x. I'm going to the negative 2. Minus 2x squared minus 4x minus 8. What zeroes out? Positive 2x squared, negative 2x squared. Positive 4x, negative 4x. Notice that all you have left is x cubed minus 8. Here we go. Y prime. I would really, really like for you guys to recognize that as difference of cubes, but it's fine if you don't. What's the derivative of x cubed? 3x squared. And then that's it. All right. Understand that in normal circumstances, we would have done product and quotient. We're not going there, guys. Just perfect your product rule. Perfect your power rule. So log into Delta until they call you guys out. And there's 2 deltas. You're not going to do the second one. Notice that I put in there, it's not homework. We're going to do the second one tomorrow and last. All right, we're done, guys.